In South Australia, Tesla has a massive battery plant next to a wind power plant. A company called STORAGE1 is working on a spinning mass to be used in power plants. A company called Power South Energy Cooperative uses compressed air to generate. What do these have in common? These three technologies are called energy storage systems. Energy supply must equal energy demands. Renewable energy sources such as solar or wind have unpredictable outputs, and this can cause trouble if it is directly connected to the grid. This is why energy storage is needed. Energy storages can help to smooth out the fluctuations. Energy storages can take power when the output is higher than the energy demand, and give power when output is lower than demand. There are many types of energy storage systems, but we will talk about three, which are battery, compressed air, and flywheel. A lithium-ion battery or Li-ion battery is a type of rechargeable battery in which lithium ions move from the negative electrode to the positive electrode during discharge, and back when charging. This type of energy storage is the fastest, and this makes it very well suited to solar energy, because the outputs of solar panels can change in an instant. Tesla, Inc. built the Hornsdale Power Reserve adjacent to the Hornsdale Wind Farm. It is promoted as the largest lithium-ion battery in the world. Its 100 megawatt output capacity is contractually divided into two sections: 70 megawatt running for 10 minutes, and 30 megawatt with a 3 hours capacity. The system helps to prevent load shedding blackouts and provide stability to the grid, while other generators can be started in the event of sudden drops in wind or other network issues. The compressed air energy storage system works on storing compressed air when output is higher than the demand, and uses the air to run a turbine when output is lower than demand. Energy first comes from energy source like windmills. The energy then drives a compressor to rise the pressure of the air. Due to the pressure rise, the temperature also increases. The hot air then goes to the accumulator to get the heat extracted. After that, air goes to salt caverns to be stored. When energy is needed and the windmills stop turning, air can be released and heated in the accumulator, and then power a turbine to generate electricity. The electricity is released to the grid to be used. As the name indicates, kinetic energy is the key source for flywheels to store energy mechanically. The system includes cylinder mass, a rotor, and bearings to keep the flywheel in place. When an excess amount of energy is produced, the energy goes to an electric generator. The energy goes to an electric generator. The electric generator drives a motor to spins the flywheel, and the flywheel stores the energy as momentum. When energy is needed, we let the flywheel's momentum drive the generator to generate electricity.
Hi, so we're here in the Faculty of Engineering in the 30-year building, and we're here to talk about this flywheel assembly, and that is supervised by Professor Matthew here, and he's going to talk about a bit more detail about the assembly.
So this system is a test system, but it's been designed as an energy storage flywheel. So the idea is that when the flywheel spins, we can store energy. So the higher the speed of the flywheel, the higher the stored energy. And then if we want to, we can extract energy back from the flywheel by slowing the flywheel back down again. So one of the problems that we have with the flywheel system is that when the flywheel is spinning, it can cause vibration, and so we have to have a special design of bearing support to try and minimize the vibration of the flywheel. And this was the project which Ben worked on for his cooperative education project, was to design a damping system for the bearing on this flywheel. So he designed a bearing system which controls vibration using permanent magnets, and the permanent magnets create eddy currents in a copper plate, and this dissipates and converts vibration energy into heat. So it helps to prevent the build-up of vibration when the system is operating.